So test the convergence of the series. So this is summation n is equal to 1 to infinity n plus 1 x whole power n by n power n plus 1. So you take one, this is equal to un. So let un is equal to n plus 1 power n x power n by n plus 1. The un contains, or this series contains x power n. So we use ratio test. That means if the series contains factorial a raised to n, x raised to n, etc. If this series contains any one of this term, we can use the ratio test. So let uf, then for your ratio test we need un plus 1. So how will you find un plus 1? Replace n by n plus 1. Here n, each n we replace by n plus 1. So instead of n we can put n plus 1. So n plus 1 whole power n plus 1 x power n plus 1 whole divided by n plus 1 whole power n plus 1 plus 1. So this is equal to n plus 2 whole power n plus 1. This is not 2, this is 1. X power n plus 1 by n plus 1 whole power n plus 2. So this is 1 only. Now we can rearrange this term as n plus 2 whole power n plus 1 can be written as n plus 2 whole power n into n plus 2 whole power 1 and x power n plus 1 by, this is n plus 1 whole power n plus 2, that can be written as n plus 1 whole power n into n plus 1 whole power 2. This base are equal, so we can add this power, that is a rule. So we can split this n plus 2 into n and 2. Now we can use the term that is un plus 1 by un. The ratio test need un plus 1 by un. So un plus 1 is this one into its reciprocal un. So reciprocal of the un we can multiply. So that is equal to n plus n power n plus 1 by n plus 1 power n x raised to n. So this x raised to n and here x raised to n cancel, we can get x power 1. So our answer or the remaining term is here n plus 2 power n, here also n plus 1 power n. So these two terms have the same power, so we can write n plus 2 divided by n plus 1 whole power n. And you collect these two terms, that is these two terms can be written as n power n into n power 1. So that is n power n into n divided by here n plus 1 whole power n. So here one remaining term that is equal to n plus 2 here. Here one remaining term that is n plus 1 the whole square. And here one remaining term that is x. So this is the simplification. Now you take this n plus 2 by n plus 1 as whole power n. You collect these two. These two terms have the same power n. So n by n plus 1 whole power n. Remaining here one n, here n plus 2, that is n into n plus 2. Denominator contains one more term that is n plus 1 the whole square. This remaining x. Now applying the limit n tends to infinity. Limit n tends to infinity, that is equal to, here you can take n as common, that is if you take n common inside the bracket, don't take outside, that is inside the bracket, so n into 1 plus 2 by n. So here no n, so we can write in the denominator. So here no n, so we can write in the denominator. So n and n will be cancelled, remaining but 1 plus 2 by n divided by 1 plus 1 by n whole power n. Here also we can take one n as common, that is n. Denominator you take n into 1 plus 1 by n. That n will be cancelled. You can get 1 by 1 plus 1 by n whole power n. Here also we can take n square. So n square into 1 plus 2 by n. Why here n square? From this you take one n. That n into n is equal to n square. Here power is equal to 2. Therefore we can take n square as common. So 1 plus 1 by n the whole square. Now applying the limit n tends to infinity. So if you put limit n tends to infinity, here we need one formula. So for that we need the reciprocal of this term. What is the reciprocal of this term? 2 by n is equal to n by 2. So that is why we in the power we divide by 2 and multiply by 2. Divide by 2 and multiply by 2. That means these two cancel, we can get the original one. So if you get n by 2, that term is the reciprocal of 2 by n. Reciprocal of 2 by n. So same way here reciprocal of 1 by n is n by 1. So that is okay. Here also reciprocal of 1 by n is n. So for these three terms, that term contains power n. That is why we use that technique. Contains the reciprocal terms of the inside, that will be that is in the numerator, in the power. Now applying the limit means this is equal to e. 1 by 1 plus n whole power 1 by n, or 1 plus n whole power 1 by n. So that is the way. So this value is equal to e square. This value is equal to e. So e square by e. Here also 1 by e into here 2 by n infinity. Applying infinity, 2 by infinity equal to 0. 1 by infinity is equal to 0. That is why answer 1 by 1. So total value is equal to e square by e. This one e. This is e square. This is e square. This is e. And this is e. Into 1 into remaining one x. That means this e square, everything will be cancelled. You will get only 1 x. By ratio test, if the limit is modulus limit less than 1, it converges, and greater than 1, it diverges. That means modulus of x, the given series converges if mod x less than 1 and diverges if mod x greater than 1. So this is little difficult problem. So you try it, and we can go through another two problems.